Hello Math Model students. I thought I would take just a moment and go through a few of these problems, as many as I can before the bell rings anyway. We'll start with problem 1. Suppose a taxi driver charges $1.75 per mile. Fill in the following chart with the correct values for f of x, or the cost of a trip of x miles. The most important step in problem 1 is to create the function, the equation or function that's being referred to in this word problem. So a taxi driver charges $1.75 per mile. So we have to ask ourselves, what is the dependent and independent variables in this function? Well, the dependent variable is the cost of the trip, all right, because it's 1.75 or $1.75 times the number of miles. Think about it like that. So f of the number of miles equals $1.75 times the number of miles. So the dependent variable, this is the dependent variable, that's the cost of the trip, the total cost. And the independent variable is what's being represented by x in this problem, is the number of miles. Number of miles is the independent variable. In other words, the number of miles does not depend upon the cost of the trip. Rather, and it makes more sense just logically, the cost of the trip depends upon the number of miles. So when we plug in values for x, what we're really plugging in is number of miles. And where I got that is a taxi driver charges $1.75 per mile. So if I say, well, what is the cost for 1 mile driven? Well, that would just be 1.75 times 1 mile would just be $1.75. 1.75. If I go 2 miles, well, I just plug in 2 for x, and we get 1.75 times 2, or 3.5. So this is $3.50 total trip charge. How about 5 miles? 1.75 times 5. That's $8.75. How about 7 miles? 1.75 times 7. 12.25 or $12.25. How about 9 miles? 1.75 times the number of miles. In this case it's 9. So plug in 9 and get 15.75 or $15.75. Those are the values. All right. Now it's interesting. I could go to stat edit and plug in my y values and my x values. I guess I'd plug in my x values first and then my y. So 1, 3, 5, 7, 9, and go over to L2 and put 1.75, 3.5, 8.75, 12.25, and 15.75. And then go to y equals, delete anything that's there, go up to plot 1, turn plot 1 on by hitting enter, and then once that's selected, hit graph. Then hit zoom stat in order to zoom correctly for that stat plot zoom stat, and you see that I have a vaguely linear relationship, okay, upward sloping. And so if I wanted to fit this to a linear equation, I could do that by going to stat, calc, linreg, enter, 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 and I see that it's giving me a slope of 1.8375 and a b value of negative 0.78. Now that doesn't make sense to me, because it seems like the slope should be 1.75, but that's why I don't trust the calculator. So either I made a calculation error in here, let me go back and check, or there's just, it's one of those things you can't trust the calculator for. 1.75 times 3. Oh, that was my mistake. 5.25. That should be 5.25. Okay, that was probably the error right there. So 1.75 times 5. 1.75 times 7. And okay, looks like that data is now correct. So let's go back to and correct this. This is 5.25. I bet that everything will look better now. Yep, now it's perfectly linear, and I bet if we go to stat, calc, linreg, we'll get 1.75 for A and 0 for B. There we go. That's what we wanted. This was actually a good mistake to make, because it shows that when you do it right, your intuition about mathematics should work. So checking the values that way was a good way for me to find my error. That was unintentional but instructive. All right, that's number 1. Thank you.